Hello my dear friends, welcome to my YouTube channel. Myself Dattu Patel, Assistant Professor from LJIT. Today's session we are going to discuss about the half-range Fourier series. Basically, half-range Fourier series in interval 0 to L, which has two types, half-range cosine series and half-range sine series. Firstly, why we are called it is half-range series? Because it is on the interval 0 to L. Above lecture, we solve the 0 to 2L or minus L to L, but it is a half interval. That's why we call it is a half range Fourier series. Firstly, in above lecture, we are taken the finding the values of L. For that we have to taken the formula 2L equal to distance, but here we have to use L equal to distance. That is our formula to finding the values of L. Firstly, we have to discuss the Fourier cosine series of the function on the interval 0 to L is given by f of x equal to a0 by 2 plus summation where n is running from 1 to infinite an cos n pi x by L, where a0 equal to 2 by L integral 0 to L f of x dx. Now an equal to 2 by L integral 0 to L f of x cos n pi x by L dx, and finding the a0 and an and substitute in this equation, that will give you Fourier cosine series, that is half range of cosine series. Similarly, Fourier sine series of the function in the interval 0 to L is given by f of x equal to summation n equal to 1 to infinite bn sin n pi x by L. Now where bn equal to 2 by L integral 0 to L f of x sin n pi x by L dx. Finding the values of bn and substitute in this equation, then we will get sine series. In our lecture, we have to learn about the even and odd function. If whenever we apply the even function, then values of bn is 0, and whenever we apply the odd function, then a0 and an 0. Similarly, here we have the whenever we finding the cosine series, then finding just a0 and and whenever we finding the sine series, then we finding the only bn. But here same function has a finding the cosine series, also finding the sine series. Because it is a half interval, then for that we have the same function as a cosine series and also same function as a sine series. We can finding the both the series of the same function. Let's see one example. Find the half range sine series of the function e raised to x where interval which is 0 to L. Firstly, we have to finding the values of L. Then we have the formula L equal to distance. Then L equal to distance which is L minus 0. Then small l equal to capital L. Then finding the half range sine series is f of x equal to summation where n is running from 1 to infinite bn sin n pi x by L. Here we use capital L because small l equal to capital L. Now we have to finding the first values of bn, then substitute it. Then bn equal to 2 by L integral 0 to L f of x sin n pi x by L. Here replace small l as a capital L, then here we use capital L. Now here our function which is e raised to x, then 2 by L integral 0 to L e raised to x sin n pi x by L dx. Here we cannot go for directly integration of product rule, means we cannot apply the integrating by parts or Barr rule equations. For that we have the formula which is already learned in 12th science, integral e raised to x sin bx dx equal to e raised to x upon a square plus b square a sin bx minus b cos bx plus c. For that a equal to 1 and b equal to n pi by capital L. Substitute this value in this equation and that will give you 2 by L inside the bracket e raised to x upon 1 square plus n square pi square by L square inside the another bracket sin n pi x by L minus n pi by L cos n pi x by L, where which is x which is running from 0 to L, that is our limit. Now we have to substituting the limits. For that, firstly we have to simplify that term, then after applying the limit, then 2 by L e raised to x upon 1 square plus n square pi square by L square inside the bracket sin n pi x by L minus n pi by L cos n pi x by L, where x which is running from 0 to L. Now firstly in denominator portion we have to taken the LCM, then L square comes here, then L square plus n square pi square in denominator goes in numerator portion, 1L will be cancel out, that will give you 2L upon L square plus n square pi square. Now then substituting the limits, means upper limit minus lower limit, then whenever we substitute x as a L, then e raised to L, here substituting the L will be cancel out, then sin n pi, values of sin n pi that is 0 minus n pi by L as it is, LL will be cancel out, then cos n pi, lower limit has a minus, then substituting the 0, then e raised to 0 into sin 0 that is 0 minus n pi by L cos 0. Here values of cos 0 that is 1 and values of cos n pi that is minus 1 raised to n. Here n pi by L which is common out and LL will be cancel out, that will give you 2 n pi by L square plus n square pi square inside the bracket minus e raised to L minus 1 raised to n plus 1, that is our answer of Bn. From the equation 1, that is a half range sine series is given by whenever we substituting the values of Bn in this equation, and that will give you e raised to x equal to summation where n is running from 1 to infinite inside the bracket 2n pi upon L square plus n square pi square inside the another bracket e raised to L into minus 1 raised to n plus 1 into sin n pi x by L. That is our equation of the half range sine series. Let's see one more example. Find the half range Fourier cosine series of the function f of x equal to sin x where 0 less than x less than pi. Firstly we have to finding the values of small l, then small l equal to distance, that is L equal to pi minus 0 means L equal to pi. Then whenever we finding the values of L, then substituting in equations of the Fourier cosine series which is given by f of x equal to a0 by 2 plus summation n equal to 1 to infinite an cos n pi x by L, values of L that is pi, then pi will be cancel out, that will give you cos nx. That is our equation number 1. Then we have to finding the a0 and an. Then firstly we have to finding the a0, then a0 equal to 2 by L integral 0 to L f of x dx, that is the formula, but here values of L that is pi, then 2 by pi integral 0 to pi f of x dx, our function which is sin x, then 2 by pi integral 0 to pi sin x dx, then integral of sin that is minus cos x, then 2 by pi minus cos x where x is running from 0 to pi, then substituting the upper limit minus lower limit, then 2 by pi inside the bracket minus cos pi, lower limit has a minus, then minus cos 0. You all are aware about the values of cos pi, that is minus 1, and values of cos 0 that is 1, then here minus minus plus 1, here also minus minus plus 1, then that is 2, then 2 into 2 4 means values of a0 that is 4 by 5. Similarly we have to finding the values of an where an equal to 2 by pi integral 0 to pi f of x cos nx dx, here function which is sin x, then 2 by pi integral 0 to pi sin x into cos nx dx. Here we cannot integral directly because both has a trigonometric function, that at that case we cannot integral by integrating by parts or a Bernoulli's equation. For that, firstly with the help of trigonometric formula we have to simplify that term, then after integral. Here 2 which is comes inside the bracket, then our integral becomes 1 upon pi integral 0 to pi 2 sin x into cos nx dx. Then we have the formula 2sc equal to s plus s, then 1 upon pi integral 0 to pi sin x plus nx, then n will be common out, then it becomes sin 1 plus n into x plus sin 1 minus x 1 minus n into x dx. Now integral of sine, that is minus cos, that means 1 upon pi inside the bracket minus cos 1 plus n into x upon 1 plus n minus cos 1 minus n into x upon 1 minus n, where x which is running from 0 to pi. Now applying the limit means upper limit minus lower limit, means for the upper limit replace x as a pi, that means 1 upon pi inside the bracket minus cos 1 plus n pi upon 1 plus n minus cos 1 minus n pi upon 1 minus n, that is our upper limit, minus that is the sign of lower limit inside the bracket. Whenever we replace x as a 0, that is cos 0, values of cos 0 that is 1, means minus cos 0 upon 1 plus n minus cos 0 upon 1 minus n, values of cos 0 that is 1, and we have the basic trigonometric formula which is already learned, cos alpha plus beta and cos alpha minus beta, that means pi which is comes inside the bracket that will give you cos pi plus n pi, that is the formula of cos alpha plus beta, that is a cos alpha cos beta minus sin alpha sin beta. Similarly cos alpha minus beta, that is cos alpha cos beta plus sin alpha sin beta. You all are aware about the values of cos pi, that is minus 1, values of cos n pi, that is minus 1 raised to n, sin pi that is 0, 0 into anything 0. Similarly here cos pi that is minus 1 and cos n pi that is minus 1 raised to n, and sin pi will be 0, 0 into anything 0, that will give you minus 1 raised to n. Substituting this value in this equation and simplified that term, and that will give you 1 upon pi inside the bracket minus 1 raised to n upon 1 plus n plus minus 1 raised to n upon 1 minus n minus another bracket minus 1 upon 1 plus n minus 1 upon 1 minus n. Here in first term minus 1 raised to n common and taking the LCM, then 1 minus n plus 1 plus n, in denominator portion 1 minus n square. Similarly in second term taking the LCM, then minus sign inside the bracket 1 minus n minus 1 plus n upon 1 minus n square. Now simplified that term, that means 1 upon pi minus 1 raised to n 2 upon 1 minus n square minus 2 upon 1 plus n square. Here in numerator portion 2 will be common out, that will give you 2 by pi minus 1 raised to n plus 1 upon 1 minus n square, where n greater than 1. Here we substitute the values of n equal to 1 in this equation, then denominator becomes 0. For that we cannot consider the a equal to 1, means that is value for a not equal to 1, means we have to finding the a1 separately. We cannot consider for the n equal to 1, means our series which is starting from 2 to infinite. Suppose in denominator portion we have the value 2 minus n, then that is a not equal to 2, means whenever we substitute the n equal to 2 in denominator portion, that is becomes 0, means our series that is undefined at particular 2 position. Here our series undefined at particular 1 position, means for a not equal to 1 we cannot find it directly at this equation, means at this equation our series becomes undefined. For that we have to finding the values of a1 separately. Then our half range cosine series is given by f of x equal to a0 by 2 plus summation where n is running from 1 to infinite an cos nx. Then here for a not equal to 1 means we have to find the a1 separately, means we can written as a0 by 2 a1 cos x plus summation n equal to 2 to infinite an cos nx. Then firstly we have to finding the values of a1. Then similarly substituting the n equal to 1 in formula of an, a1 becomes 2 by pi integral 0 to pi f of x cos nx, when n is replaced as a 1, then cos x dx. Then function is a sin x, then 2 by pi integral 0 to pi sin x into cos x dx. This 2 comes inside the brackets, then our integral becomes 1 upon pi integral 0 to pi 2 sin x into cos x. You all are aware about the formulas of basic trigonometric function. 2 sin theta cos theta, that is sin 2 theta, that means 1 upon pi integral 0 to pi sine 2x dx. Integral of sine, that is minus cos, that means 1 upon pi minus cos 2x by 2, where x which is running from 0 to pi, then substituting the limits, that means upper limit minus lower limit means 1 upon 2 pi minus cos 2 pi plus cos 0. Values of cos 2 pi, that is 1, and values of cos 0, that is also 1. But here sine which is minus 1, then minus 1 plus 1, that is 0, then 0 into anything 0 means our a1 becomes 0. Now substituting this all the value means a0, a1 and an in our equations of the half range series, that will give you the half range Fourier cosine series is given by f of x equal to a0 by 2 plus a1 cos x plus summation where n is running from 2 to infinite an cos nx. Now a1 equal to 0, values of a0, that is 4 by pi, then 1 by 2 into 4 by pi plus a1 equal to 0, then 0 into anything 0 plus summation n equal to 2 to infinite, values of an, that is 2 by pi minus 1 raised to n plus 1 upon 1 minus n square into cos nx. Here simplified that term, that means 2 2s are, that will give you 2 by pi plus that 2 by pi which we constant comes out, then 2 by pi, and substituting the n equal to 2, 3, 4 etc. Then inside the bracket minus 2 by 3 cos 2x, whenever we substitute n equal to 2, whenever we substitute n equal to 3, that will give you minus 2 by 15 cos 4x and so on. Now here 2 will be common out, that will give you sin x equal to 2 by pi minus 4 by pi 1 by 3 cos 2x plus 1 by 15 cos 4x and so on. That is exactly we have to finding the cosine series of the function sin x. Let's see some practice example. This is all about the practice example, which is try yourself. This is all about the topics of the half range cosine series and half range sine series. I hope you guys you learn something from this video. If you like this video, then thumbs up. If you think that this video will help some of your friends, then do the share with them. If you want to watch more tutorial like this, then you can subscribe my YouTube channel, and whenever I upload the new video, you get the notification. If you have any query regarding this, then feel free contact me. Thank you so much for watching me.